Hello. Today is Unit 12, Day 4, and we are going to look at recursive formulas. We've previously learned that explicit formulas for arithmetic and geometric sequences. Now we will look at recursive formulas. A recursive formula is a formula that defines each term of a sequence by using the preceding term. Recursive formulas must always state the initial term or terms of the sequence. So basically, we're going to find a term by looking at a term. We're going to be able to determine what comes next rather than writing a whole list of them. So anyway, explicit, which is what we've studied before, allows you to find any term. I can find the first term, the last term, the fifth term, the sixth term, anything I want, right? But a recursive allows me to find the next term. Okay, let's look at this. These are formulas that you already have in your notes. A1 plus n minus 1 times d for arithmetic, and an equals a1 times r to the n minus 1 for geometric. These are the ones that you've already done. We've spent 2 days on them. Recursive, right, means that we're going to write a to the n minus 1 plus d, or r times a to the n minus 1. We'll look at some examples and that'll make sense. Okay, so write the first 5 terms of each sequence. Well, here we know that a1 equals 7, an equals a to the n minus 1 minus 12. That just means the term, right? So you take any term, whatever term they give you, you subtract 12 and that gives you the next term. Now I want you to notice right here that this says n is greater than or equal to 2, right? That's because if we plug 2 in, 2 minus 1 is 1, and that's a 1. We don't want to get, if I didn't specify this and you plug the number 1 in or the number 0, we would get a negative here, and we don't want to do that. Okay? So if A1 is 7 and any term, and the term I'm looking for is the term I have minus 12, then A2 is simply 7 minus 12, or negative 5. A3 then, I'm going to plug in negative 5. Negative 5 minus 12, which is negative 17. A4 is going to be negative 17 minus 12, which is what? Negative 29. And then A5 is negative 29 minus 12 equals negative 41. So notice what's happening here. Instead of our other ones, like when we looked at arithmetic, we noticed the slope was the difference and it would just go up by the slope. On a recursive formula, you're taking the answer that you just got and you're putting it in here, and then you're following that rule. So you keep subtracting 12. Hopefully that makes sense. Let's look at the next one. Okay, so A1 equals 3. What am I supposed to do to it? That's my 3, so I'm going to say 4 times 3 minus 3, right? So A2 then is going to be 4 times 3 minus 3, which equals 9. Notice if we can highlight this, this refers to the last term. So this time, right, I'm going to have that opened up. That part doesn't change. It's 4 times the last term minus 3. So now I have to look at the term before and put it in there. Hopefully this is making sense. This gives me a rule: 4 times the number minus 3, 4 times the number minus 3 And what we plug into that parenthesis is this last number, right? And then, of course, this said the first 5 terms. So we have A5 equals 4. I'll put that answer in. So let's think about what's happening. They give me a rule. I follow the rule, but instead of plugging 1 in and then plugging 2 in and then plugging 3 in, right? What I'm doing is I'm following that rule, and instead of plugging in 1, then plugging in 2, then plugging in 3 like we did before, I'm plugging in the answer each time into that spot, okay? So I'll pause this for a second and let you make any notes you want to yourself. So if you need to make some notes, hit the pause button. Okay, so now let's look at what happens if they want us to actually write the formula. You'll have to make a decision, and you'll have to decide arithmetic or geometric. And we decide that, we look at the numbers and we figure out, are we adding the same number each time, or are we multiplying by a number each time? Well, I can tell here that I'm multiplying by -3, multiplying by -3, multiplying by -3. And if I'm multiplying, it's geometric, right? So R equals -3. So what you're going to do, right? Here is the formula. AN equals R times A to the n minus 1. In order to write the formula, you're going to replace the R. So you're going to say AN equals, I'm going to change -3 times A to the n minus 1. So all you're doing to write your formula is replacing the R with whatever you found R with. This A to the n minus 1 stays the same, because remember, where you get that is from your last answer, right? So if I know here that A to the n, A1 is 7, I would plug that in and get -21. Then I'd put -21 in there to get my next answer, right? Now, as we look at this one, -3 times 4 would give me -12, but -12 times 4 would be 48. So this is not geometric. Let me check to see if it's arithmetic. So -3 minus 9 is -12, minus 9 is -21, minus 9 is 30. So this one is arithmetic because we have a difference. A1 is -3, and the difference is -9, going down. So I'm going to rewrite it. Remember from our formula for arithmetic, AN equals A to the n minus 1, meaning the term before, plus D. All we're going to do here is replace the D. So my formula is going to be A to the n equals A to the n minus 1 plus, well, in this case, minus 9, right? That's going to be a minus because it's -9. We leave this here because this tells us if I wanted to write all these out, I would take the answer before and subtract 9. When I get that answer, I plug it in and subtract 9. Okay, remember, recursives allow us to find the next formula. So let's go down here, and for each recursive formula, write the explicit. For each explicit, write a recursive. So the first thing you have to do is decide if this is recursive or explicit. This is already recursive. If it's recursive, I want to write the explicit. So what do? I'm going to replace, right, R, right? So this is 0.2 to the n minus 1. So I know that that's geometric because it's multiplied, right? So a to the n is going to equal r, which is 0.2, right? And then my first one, which is 9. So I'm going to say 9 times 0.2 to the n minus 1. And that comes from our geometric explicit, right? It's a to the n equals a1 times r to the n minus 1. You have this in your notes, but I want to be able to point at it. So what we do, right? a1, r to the n minus 1, we write a1 down, which we've been told is 9, and we fill r in, which we can see is 0.2. Okay, let's look at this one. This one is recursive, right? Now I can see that this one is arithmetic, not geometric. So an explicit one should look like this, right? It should be y equals mx plus b, basically, right? So I'm going to want an equals, what does it equal? Well, negative 7n minus 9. Where did we get that? Well, I can see here that the difference is 7, which we noticed as we did these before, goes right there. Now, what about the negative 9? Well, I'm starting at negative 16 and I'm going down 7. So if I'm going from negative 16 and I'm going down 7, I'm now at negative 9. So there is my recursive formula, right? Now, I started with recursive, there's my explicit. This time, we've been given an explicit formula. An explicit. So now it says, if we're given explicit, write it as recursive. So A1 here, remember for recursive, we have to know A1. So I'm going to plug 1 in there. A1, if I plug 1 in here, 6 times 1 is 6 plus 3 is 9. The difference is 6. We learned that when we studied these with arithmetic sequences, that's the difference. So my recursive formula is going to be a to the n equals a to the n minus 1 plus 6. And I have to specify that n is greater than or equal to 2. Because if I put a number smaller than 2 in there, this would be less than 1, and we start with 1. Okay, right here, A1 is, if you plug a 1 in here, 1 minus 1 is 0. 0.8 to the 0 is 1. 1 times 120 is 120. R is 0.8. So to write this as a recursive, I look at the formula, right? Recursive is, let's write this, right? So all I do is replace the R. Here we replace the D, here we replace the R. So let's kind of review what our steps are. If I'm given explicit and I want to write it as a recursive, I replace the D and I replace the R and I'm finished. Okay, not too bad. All right, start on your homework. Hope you have a great day.